Hello everybody. This is our part 2 of our end semester exam solution and myself Ashish Verma. So let's begin. Uh, Question number 5th A. Distinguish between parametrics versus non-parametric models and supervised versus unsupervised learning with examples. Parametric models assume a fixed functional form and a predetermined number of parameters. They learn only those parameters from data. These models are simple, fast, and work well when the assumption fits the data. Example: linear regression, logistic regression, naive Bayes. Non-parametric models make no strong assumptions about the data's functional form and can grow in complexity as more data becomes available. They are more flexible but computationally heavier. Example: k-nearest neighbors (KNN), decision trees, random forests, kernel density estimation. Supervised learning uses labeled data where each input has a known target output. The model learns to predict the output for new on-chain inputs, classifying complaints into offense types, predicting severity scores from features. Unsupervised learning uses unlabeled data to discover patterns, structure, or groups without predefined targets, clustering complaints into thematic categories, detecting unusual cases through anomaly detection. Now, our accuracy physician recall FN score and illustrate their computation using confusion matrix. Accuracy measures the overall correctness of a classifier. The formula of accuracy is equals to TP plus TN by TP plus TN plus FP plus FN. Here TP means true positives and TN means true negatives and FP means false positives plus false negatives. So in our dataset, by this formula we'll get the accuracy of 0.85. Now precision. Precision measures how many of the instances predicted as positively are actually positive. It focuses on the quality of positive prediction and is important in applications where false positives are costly. Precision is equal to TP upon TP plus FP. Here our precision is 0.888. Recall, also called sensitivity, measures how many of the actual positive instances were collectively identified. It focuses on minimizing false negatives and is important when missing positive keys is risky. Recall is equals to TP by TP plus FN. So in our dataset, the 0.80 is our recall value. The FN score is the harmonic mean of precision and recall. It provides a single measure that balances both, especially when classes are imbalanced or when precision and recall needs to be jointly optimized. Two times of recall and precision by sum of recall plus precision. In our dataset, it will give us an estimated value of 0.842. Now, with a further question, 6th A, describe how the coefficients in linear regression are estimated using either the closed form equation or gradient descent. In linear regression, the goal is to estimate coefficients, weights that best fit a line or hyperplane to the data. The coefficients are chosen so that the sum of squared errors between predicted and actual values is minimized. Closed form solution. Normal equation. The coefficient can be computed directly using the formula. Here, x is the design matrix of input features and y is the output vector. This solution gives the exact least square estimate in one step, but it becomes computationally expensive when the number of features is very large. Gradient descent. Gradient descent is an iterative method that starts with a random coefficient and gradually improves them by moving in the direction that decreases the error. For each update, the rule is here, where alpha is the learning rate, iterations continue until the error coverages. Gradient descent is preferred for larger datasets of high dimensional problems because it avoids metric intervention, inversion and scales efficiently. In summary, the closed form method is exact but expensive for large data, while gradient descent is approximate but scalable and widely used in practice. Explain logistic regression and use the logistic function to calculate the probability of a class for a given input example. A logistic regression is a classification method that predicts the probability of an input belonging to a particular class, usually the positive class. Instead of fitting a straight line, it uses the logistic sigmoid function to squash the output into a value between 0 and 1. The model learns coefficients that define a linear combination of features, and the logistic function converts that value into a probability. Logistic function is equals to p of class is equals to 1 by x, which means by 1 upon 1 plus e minus e to the power minus z. Calculating probability, so the probability here is 0.8176. Now, write the k-means clustering algorithms. Discuss how initial centroids influence results. First, k-means clustering algorithms. Choose the number of clusters k. Second, randomly select k initial centroids from the dataset. Third, assign each data point to the nearest centroid, forming k clusters. Recompute each centroid as the mean of all points assigned to that cluster. Reassign points to the nearest update centroid. Repeat steps 4 to 5 until cluster assignment stop change or a maximum number of iterations is reached. The algorithm output k clusters and their centroids. Influence of initial centroids. The choice of initial centroids strongly affects the final clustering. Poor initialization may lead to different final clusters for the same dataset. Suboptimal solutions, which is also called local minima. Uneven clusters or empty clusters. Longer convergence time. Better results can be achieved using smarter initialization methods such as k-means plus plus, which spreads out initial centroids to improve stability and clustering accuracy. Now, write the k nearest neighbors algorithm using Euclidean distance. KNN is a simple instance-based learning method that k nearest neighbors method that predicts the class of new data point by looking at the classes of its nearest neighbors. How the algorithm works. Select the value of k. Choose how many neighbors you want to consider. Example k 3 or 5. A small k makes the algorithm sensitive to noise. A larger k gives smoother results. Calculate the Euclidean distance between the new input point x and each point xi in the training dataset. Why we are using Euclidean distance? This is the main question that arises because we use this because it works well when features are continuous, captures the geometric closeness of points, must be used with feature scaling to avoid dominance by large valued features. Now compare decision trees, random forest, boosting, highlighting strengths and weaknesses of each. Firstly, decision trees. A decision tree splits data into branches based on feature values. Its strengths are simple to understand, easy to visualize, handles both numbers and categorical data, and requires little preprocessing. Its weaknesses are highly prone to overfitting, unstable, changes in data, and can be the tree, and generally less accurate compared to ensemble methods. Now, random forest. A random forest builds many decision trees on different bootstrapped samples and averages their predictions. Its strengths are it's much more stable and accurate than a single tree, reduces overfitting, handles noisy data well, and works well by default. Its weaknesses are less interpretable than a single tree, requires more computation, and may struggle with high dimensional sparse data. Boosting example ADA boost, gradient boosting. Boosting builds trees sequentially, where each new tree focuses on correcting the errors of the previous ones. Strength very high predictive accuracy, excellent for complex patterns, reduces bias effectively, and often outperforms other methods. Its weaknesses are sensitive to noise and outliers, slower to train, and easier to overfit in non-tuned properly. Now, explain the architecture and components of Hadoop, HDFS, Yarn, and MapReduce. HDFS, Hadoop Distributed File System. HDFS is the storage layer of Hadoop. It splits large files into blocks and that them across many machines. Name mode manages the file system metadata, directory structure, block location. Data nodes store the actual file blocks. HDFS provides fault tolerance by replicating data blocks across multiple nodes. Yarn, add yet another resource negotiator. Yarn is the cluster resource management layer. Resource manager allocates CPU and memory to applications. Node manager monitors resources on each worker machine. Yarn allows multiple applications, MapReduce, Spark, Hive to run on the same cluster. MapReduce is the computation framework. Map phase processes input blocks in parallel and output keys, value pairs. Reduce phase aggregates and summarizes those key value pairs. It is fault tolerant but disk heavy because every stage writes to HDFS. Now obtain basic logical gates from neural networks, summarize them in a table with the number of neurons. AND gate implemented using a single perceptron uses positive weights and a high threshold, so output is 1 only when both inputs are 1. Uses a step threshold activation function. No big propagation since it is separable, linearly separable. NOT gate requires only one neuron and one input. Uses a negative weight, so one input becomes output 0 and vice versa. So back propagation needed. OR gate implemented with one perceptron uses positive weights but a lower threshold than AND. Step activation function. No back propagation required. NAND and NOR gates. Each can be implemented using one perceptron, achieved by flipping the signs of the weights used in and or step activation. No back propagation since they are linearly separable. So, by with this topic, we end our conversation. Thank you. Thank you for listening.